I think you're good.
Is this working now?
Yeah.
Okay. So okay. Fantastic. Okay. Great. Nice. We lost the clicker.
No.
No. Oh well. I'll just click from here. That's all right.
Sure.
No worries. Okay. All right, great. So I'll just start off with this observation that the human moral mind is flexible. Is it morally permissible to get a haircut during a global pandemic? Before the year 2020, none of us had ever considered that situation before. And there doesn't need to be a worldwide pandemic for the moral landscape to change. There might be a new technology, for instance, and we have to figure out if it's permissible to use or develop it. Or someone might tell you that there's a Sydney zoo, and you have to wonder about whether it might be morally permissible to live in a zoo or not. And things might change if you discover that a main attraction of the Sydney Zoo is hyena encounters, and you might have to update your representation if you'll realize that this is the only hyena encounter that you'll ever have. But humans aren't the only ones making these kinds of weird moral judgments anymore. AI systems are also starting to do this. And the question that I have been thinking about quite a bit is how can we make AI systems to make human-like moral judgments, to have the kind of flexibility to encounter novel moral situations in the way that humans do. Okay, so my fairly straightforward answer to this question, if we're going to try to give AI systems a human-like moral sense, is to just figure out the way that humans do it, and then write that down in precise computational terms, such that an AI system can then do precisely what a human does. Now, of course, this has many challenges to it. First being that we don't know how humans make moral judgments in precise computational terms yet, though we've made some progress on that, and I'll talk about that in a second. But the part of the vision here is that if we attempt to do this hard work in cognitive science, figuring out how humans make moral judgments, that will help us in turn figure out how we can make AI systems do the same. And that will then lead to this positive feedback loop. Once we try to figure out how we can incorporate moral judgments into AI systems, that will give us some hints into maybe how humans make moral judgments as well. And throughout the talk, I'll mention some ways in which I've already kind of started to see that happening in my current work. Okay, but say we were going to start with figuring out how humans make moral judgments. And probably a fairly brief, though I think actually meaningful schematic, is that humans often take some natural language and then it enters them, and then something happens such that they get a moral judgment. And you might think, well, this is not so informative if what we're trying to do is create an AI system that does something like this. But actually, there is quite a long history in cognitive science of thinking about human moral judgment in precisely this way. So this is a diagram that I spent a lot of time looking at in graduate school. This is from a paper that one of my graduate advisors, John Mikhail, wrote. And he was a student of Chomsky, and you might recognize this as a sort of Chomskyan way of thinking about language. You might also think about this as a kind of Marr theory of the computation way of thinking about any kind of cognitive system. And what Mikhail tried to imagine as a way of thinking about the human moral mind is that you take an input, the mind does something to it, and then we provide a moral judgment, either if the input was permissible or impermissible. And so what Mikhail did was he thought about trolley problems most frequently, but his solution to what was going on inside the moral mind was a sort of moral grammar. And he broke that grammar down into a series of information processing steps. So first we start off here with the stimulus, and then there's some kind of set of conversion rules that takes a stimulus and then forms a structural description of what was in that input originally. And then once we have that structured description of what's going on in the moral scenario, we apply a series of deontic rules to it, and thereby getting a response. So already, this is a kind of roadmap for how we might try to build AI systems if we're modeling them against what human moral cognition looks like. Okay, so I spent a large part of my graduate work and my postdoc thinking about just this part of the equation. What are those deontic rules that people seem to use to operate over structural descriptions to ultimately get a response? But we basically have no idea what goes on before that happens. So that is, right, here's all the work that I did. Oh my gosh, there's so much, but still we know so little. But we know almost nothing about what's going on this side of the graph, which I'll call creating a moral world model. So that's something that we're starting to think about at the Allen Institute. But given that there's very little work in the cognitive science of morality on how exactly this happens, how we go from a stimulus to a structured description, what are we going to do about that if we want to make an AI system modeled off of morality? Okay, so the kind of thought that I have here and the vision that I've been working on for the past year or so is that this is ultimately what we want to do. So we know a bit about what happens in this step. Once we have a moral world model, we can apply computational moral psychology to it and get a moral judgment. But because we know so little about what happens over here, maybe we can use the power of large language models to convert natural language into this kind of structured description. And so what I'm going to do is tell you about a few different attempts we've had at doing something that about this vision, each coming slightly closer to that vision than the previous one. Okay, so I'll start off with describing this challenge set that we developed, which is going to be our benchmark for figuring out how well we're doing at predicting human-like moral judgment. And then I'll talk about 3 different attempts that we have of making this system. Okay, so what's this benchmark? This is basically a series of studies that me and my collaborators did over the past 5 or 7 years or so, where we're trying to computationally characterize human moral judgment. So all of these scenarios are things that highlight the flexibility of the human moral mind. So this one, for example, looks at how people know when it's permissible to cut in line. The reason this is interesting is it seems like there's one very simple rule about how to wait in line. You just stand at the back of the line and wait your turn. But in fact, people can, with a fair degree of precision and reliability, tell you whether it's appropriate in any given case to actually cut in line, to go to the front of the line. So this is an example of the sort of rule breaking that the mind can do. Similarly, we used a series of scenarios where people think it's okay to violate other people's property rights. And finally, a set of scenarios where there actually is no rule telling you how to act in a particular case, but people spontaneously figure out what to do in that case using an idea of universalization. And I'll talk more about that in a minute. Okay, so just to zoom in very briefly on what one of these studies looks like so you can kind of get a sense of the data that we're working with. So we have a huge series of cases where people attempt to cut in line for various reasons. We simply ask our subjects, is it okay or not okay to go to the front of the line? We do this in deli situations where people are waiting in line for bathrooms, at airports, in classrooms, and so on. So here's just one example of the data, one set of data that we used. You can see what's interesting here is that we get this graded kind of moral permissibility judgments. And the thing that we're going to try to capture in our computational modeling is the graded nature of people's judgments. They don't simply think it's okay or it's not okay, but what we're trying to do is figure out exactly why do they think it's exactly that okay. Okay, so in each of the experiments, the strategy is to figure out, well, what are the morally relevant features of this case? So, for example, in this case of studying in line, one of the morally relevant features is how much better or worse off would the person cutting in line be? And so we ask people to give judgments about that. Or we might ask, how much better or worse off would the first person in line be if that person were to cut? We have a whole series of questions like this. Here's just a small list of them. But for each of the cases that we're thinking about, property violations, novel rule situations, we have a different set of morally relevant features. We ask people to give us estimates of those features. Then once we have estimates of the features, we connect those estimates to predicting moral judgments using some kind of computational strategy. And the strategy differs across the different projects, across the different experiments. So in this particular one, we teamed up with a group at IBM Research, and the tool that they had in particular was this formalization called Kidder's Paribus nets. So this was the cognitive model that they designed. The point here is just that there's some connection between these morally relevant features of the case. And if you connect those in this structured form, you can predict human moral judgment. Okay, and so we do that then for the rest of the experiments, the one about violating property rights, the one about using this novel fishing hook in a situation nobody's ever been in before. If you're interested in hearing more about universalization in particular and rule-breaking judgments in that scenario, my student Joe Kwan is giving a talk about this more tomorrow afternoon. Okay. So now that you have a sense of kind of what this data looks like and what the strategies were for as when we came at this from a cognitive science perspective to try to predict human moral judgment, how do we then proceed? Okay, the one thing I want to point out here is that what I've put up here is just one example of one of the models that we use that describes how people were making these judgments. So this is, a kind of a theory of the computation level approach. It describes input-output sequence, a set of that uses a set of information processing steps. But what's interesting to note is that how do we get this world model to begin with? And I think the answer to that question is well encapsulated by this picture, which is the Sydney Observatory, which I would recommend that many of you go to visit. But the point is that the way that we created this moral world model was I thought about it, right? Like I sat there, I thought about the theory of cognitive science, I did a bunch of data analysis, and then I realized what numbers should go into that equation. So this is the Sydney Observatory method of figuring out how to construct a moral world model. But what we want to do is something more sophisticated than that. Is there a way we can get the experimenter's intervention out of this process so we can go directly from natural language input to a moral world model? So that's going to be the goal. And again, the strategy is going to be maybe we can use a large language model to do that. Okay, so here are our 3 attempts. This first one was done by led by my collaborator Zheng Jin, who's actually on the job market this year, looking for positions in the natural language processing area. So take a look out for her. And the strategy here was to look at all of the experiments that we've done and find what was common amongst the morally relevant features. And then simply to run a chain of thought model on GPT. So we noticed that one thing that was common amongst all of our strategies was to ask whether there was a rule violation, and then to ask what the purpose of the rule was, whether there was utility lost or gained for the rule violator, who would be better off and worse off. So what we simply did was we asked the language model to take into account all of these things that had gone into our cognitive models. And then at the end, we asked, okay, now taking all of this into account, taking into account the things that we just asked you about, would the action be okay? And we got an answer. And because this was a paper that was submitted to a computer science conference, the data is presented in this inscrutable table, but things are cleverly bolded. So you can see that our model, which we're calling the moral COT, actually does a much better job than any of the other models that were available at that time, including Delphi, which is the model the Allen Institute built, which was specifically trained to make human moral judgments. Okay, so it seems that just providing some information about what is morally relevant was useful as part of a chain of thought strategy. But how well did we do in kind of achieving this vision? And the answer is kind of not at all, right? So this is a better representation of what that paper did. We started from natural language. We just asked an LLM to give us a moral judgment. There's no moral world model here at all. And what we did was we used elements from computational moral psychology to prompt the LLM. But that was our first attempt. We saw that, okay, that was at least kind of a little successful. We did better than the state of the art, just like using what we know from cognitive science. But our next project attempts to do this in a little bit more of a rigorous manner. Okay, so this will be attempt 2. And attempt 2 is led by, again, Joe Kwan, who is an awesome full-time research assistant in Josh Tenenbaum's lab, also working with me, and he's applying to graduate school this year. Okay, so here's what Joe is attempting to do. I'm going to describe 3 different neurosymbolic approaches. So the first one takes an LLM and it prompts it with any of the given scenarios that I told you about before. So for instance, someone attempting to cut in line. And the question that we'll ask the model in particular is, which things are morally relevant? Just can you come up with what the morally relevant features are? And it does a not terrible job. Following that, we then ask it to give us values for those features. So those things that you just said were relevant, tell us exactly how good will it be for the person if they cut in line, exactly how bad will it be for the first person in line, and so on. And then once we have values for the features, we just try to put them through a linear regression model, see how well we can do at predicting human moral judgment. Okay, so that's kind of the first approach. The second approach does something just slightly more sophisticated, which is to, rather than just asking the model, what features do you think are relevant, to take that information from the cognitive theory. So we already know, for instance, global welfare is relevant, likelihood of this happening is relevant. So that's how we select the relevant features. And then we ask the model, okay, give us values for these features. And then we pass that through linear regression. And the final attempt is to use the cognitive model as robustly as possible. So we take the relevant features from the cognitive theory. We ask the LLM to give us values for those features. How long will this person have to wait? How good or bad off will the first person be? And then we take those features and we just run it back through the cognitive model. So what we're doing here is we're just taking out the necessity of running an experiment with humans, et cetera. Instead, we have the LLM tell us what the values of the environment are that we can then pass through the model. Okay. And so what we did here was we ran the previous method on this new data set. The data set was changed slightly to see how that would look. And because GPT-4 is now on the scene, we ran this experiment on GPT-4 as well. And what you can see is the most sophisticated of these neurosymbolic methods does the best. You can see it's not a huge improvement over GPT-4, certainly not, but in addition to trying to get higher accuracy, one of the values that this approach brings is a huge amount of explainability and transparency, something that is completely lacking in GPT-4. Okay, so we've actually progressed quite a bit more towards this ultimate vision that I originally sketched out. I wouldn't say that we've built a moral world model exactly, but we have used an LLM to replace the experimenter intervention in an important way. We've used an LLM to extract relevant features from natural language that then can get passed through the computational model. Okay. I'll take just 2 minutes for what I think is a super cool interlude, which is I just want to point out a really interesting way in which my work on trying to build these AI systems actually helped inform a question in cognitive science. Just talk about this super briefly. And to do that, we'll just think for a minute about the central thing that all of those neurosymbolic models were attempting to do, which was to use language models to provide values for morally relevant features. So one of the cases that we looked at was this case of overfishing. So this is a classic collective action problem. If one person does something, absolutely no problem. But if everybody does that thing, it's really bad for everybody involved. So this is a case where there's this really powerful fishing hook where if many people use it, the fish in the lake will go extinct. But if one person does it, totally fine. It'll be totally fine for the fish population. And in fact, it's good for that person because that person can get more fish. Okay. One of the things that we had to do in order to test our model of universalization, which is just a model that captures people's moral judgments in cases like this by asking, what if everybody did that? One of the things that we had to do was find out how people were representing this collective action problem. So we told them very specific things about what happens if people use this new hook in this particular environment. Up to 4 people can use it, absolutely no problem. But after that, utility quickly drops off, for instance. And that's what this graph shows. This is just a graph of how we were trying to convey things to subjects. But what we then did, after telling subjects specifically what was going to happen in this fishing world, was to just ask them to report back that information. How would the vacationers be affected if the following numbers of people use this new fishing hook? And ask them to tell us the answer on this Likert scale. And what we found was this. So this is our hypothesized idealized utility function. So we thought that, okay, utility would be basically flat before this problematic zone. Then utility would quickly drop off and then level out. Or we thought another possibility would be that utility might go up before this problematic zone because a couple of people can use this new fishing hook, and that's good for them. But then quickly, utility drops off. But here's what we actually found. People thought that utility dropped before the harm threshold. We really had no idea why that was, but we proceeded on with our paper, and we kind of shrugged. So fast forward to the current attempt to encode this model into a large language model. When we just give the direct prompts, Okay, fast forward to our current attempt, and what we find is that this is the response that we get from the language model. And this was actually one of our hypothesized ideal utility functions. Understanding the text in a certain way better than how humans were understanding it. But ultimately, that is a problem for the model's attempt to predict human moral judgment, because the model needs to understand humans' biased way of understanding the problem in order to accurately predict downstream moral judgment. So what that encourages us to do, what it requires us to do, is to understand exactly how are humans imagining this scenario such that they think that that this is the right way of thinking about the problem. Because before we can model that, we're not going to be able to judgment. happy to come back to that if anybody's interested, but like the Sydney. All right. So just the current in progress attempt at building this pipeline. And this is a project that I'm super excited about working on with Sarah Wu, who's interning at the Allen Institute this summer. And what Sarah and I started thinking about was thinking hard about what building a moral world model would actually look like. And to answer that question, we drew inspiration from a recent super interesting paper by Leo Wong, Gabe Grand, Josh Tenenbaum, and others. And I think they recorded a presentation actually for this workshop. And you'll hear Josh talk about their work more in a couple of hours or so right here. But essentially what they said was that world models, their hypothesis is that world models could be written in probabilistic programming terms. And enables a connection between natural language and a language of thought. And so the thought is that what maybe the role of a language model in this pipeline could be translating natural language into code of a probabilistic programming language. And if that's right, then what we'll need to do is take all the disparate sorts of computational mechanisms and computational tools that we have already built and write them down in a probabilistic programming language. So that's the first thing that we're attempting to do. But then what Sarah realized is that once we do that, we can solve actually a really deep problem in moral psychology, which is we can call the mechanism selection problem. So if you noticed, I talked about a few different sorts of moral problems. Like we have a problem of property violations, we have the problem of cutting in line, we have the problem of the fishing hook, and each of those have a separate cognitive mechanism that we use to describe them. But of course, now the trouble is, how do you know which of those mechanisms to use? So this is a trouble for many reasons. One, all of those mechanisms are written using different computational formalisms. Another is simply figuring out which stimulus in the environment is appropriate to each of the mechanisms. So interestingly, my collaborators and I recently proposed a solution to this problem. And the solution points out that while many of the cognitive mechanisms we personally have been interested in are these agreement-based mechanisms, those agreement-based mechanisms actually have this interesting role of connecting other sorts of mechanisms that have been used in moral psychology, rule-based and outcome-based mechanisms. And in fact, we think agreement-based mechanisms are the key to writing down a unified theory of moral psychology. So I won't go more into that now, but I'll talk much more about this on Friday morning in the Rummel-Hart Symposium. But for these purposes, one of the things that's interesting is that once we have a unified theory of how all the various mechanisms of moral cognition fit together, we can write those down in a similar format, these probabilistic programming language, and convert a moral world model into moral judgments. Okay, so I'll just stop there. I hope this gave you a little sense into how I'm kind of working at the intersection of cognitive science and artificial intelligence development. And thanks so much to my wonderful collaborators as well.
Great, thank you so much, Sydney. So we're technically on break. I think we can take like a question or two for now, but also feel free to come up to any of the speakers during the break. Maybe let's start with like 2 questions before we officially break up. Sure.
Yeah, super interesting. I found myself wondering for attempt 2, I had a violation of expectation because I expected that you would use some of these inferred features and all that to predict the model's own moral judgments and not the humans. And given that your goal is to see, create a model that makes moral judgments, I was wondering if you did that and if it was an interesting one.
Yeah, wow. I don't think we did that, but like every time I check in with Joe, he's done like 25 new experiments, and I can't keep track. So it's possible that he has, but if not, we should. Yeah, I mean, there's a little bit of a question of whether like the features that it determines are at all going to be relevant to the judgments it produces. Yeah, right. Yeah. Yeah. I don't even have an intuition about that. I don't know. Yeah. Great question. Yeah.
One more question over there.
Yeah, thanks for it. That was very nice. So I was wondering about the concept of moral world model. Because I thought, maybe naively, that moral models changes across time and across things. So what does it mean exactly that? And also the example of the fisherman, like double foot fisherman. The data comes from which kind of population? The human data, like just American is diverse population. Maybe someone else in some other part of the world would think more like.
Yeah. Great question. So just to clarify your first question, are you saying like morality seems to change across history and seems to have different instantiations across the globe? Yeah. Great question. Okay, so this is huge in AI ethics right now. I mean, just to like basically summarize one of the challenges to AI alignment, who are we aligning AI systems to? Yeah, so I have two responses to this. One is coming from a cognitive science perspective, it is easy to think of cases of moral disagreement because after all, those are cases that we want to talk about all the time because they're the cases that people disagree about. It's worth arguing about them. We get angry about them and so on. But that obscures the fact that on the vast majority of morally relevant cases, basically everybody agrees. So it's morally problematic to harm someone with no further justification. And I think even trying to figure out how to model the cases of fundamental moral agreement is incredibly difficult. That's not to say that the problem of moral disagreement is not important. In fact, it's incredibly important. And one of my major research directions right now is trying to figure out what to do about this value pluralism problem. So, I mean, one of the first steps in that program is being able to gather data from large cross-cultural samples. And so this connects to your other question, which is like, who gave the fishing hook data? And that, is American people on MTurk. That question, I think, is even more important for the cases of standing in line, which is clearly a socially constructed norm that varies widely across cultures. But even once we have that data, how then do we deal with the fact that people often disagree? So one of the things that I'm working on right now is making a model of what we're calling a moral parliament. That is just like parliamentarians get together and each advocate for their constituents. So too, we might be able to construct an algorithm that allows us to figure out how various moral systems might be able to interact and lead to a consensus. But ultimately, I think like what I want to say about that is that issue is the issue of just governance in general. We have people with a lot of different needs, and one kind of system, whether that be an AI system or a government, they're trying to take into account their needs. So like a lot of the research that I'm doing right now is trying to answer that question exactly.